just one more than the Euler Mascheroni constant. So given here is a beautiful integral which is just the product of the sine integral, or basically not the sine integral but kind of a function related to sine integral and a log function, and the product goes from 0 to infinity, and hence it's pretty beautiful Euler Mascheroni constant plus 1. And if you don't know about the small assay function, it is just the following integral from x to infinity, and with here's a minus sign, and sine t by t dt. Also with this definition we have made sure that the derivative of the SI function will just be derivative of the SI function, small SI function, will just be sine x by x. Sine x by x. We have made sure of this fact from the negative sign over here. Now let's go to solve this problem, and for this problem we will basically use the result from one of my previous video, where we basically proved this result. Integral from 0 to infinity x to the power s minus 1 si of x minus 1 si of x dx, this to be equal to minus gamma s by s sine of pi s by 2. I have already proved this in my previous video, which I will link over here and in the comment section as well. Now from this, if you just differentiate both sides with respect to s, we will be able to get the expression. So if you differentiate both sides with respect to x, the differentiation will enter the integral being a partial derivative, so we will just have x to the power s minus 1 times ln of x and then si of x dx. This will be equals to, over here we will use product rule, so one at a time. So now first of all let's differentiate minus 1 by s, so that will be 1 by s square, and others will be as it is, gamma of s sine of pi s by 2 plus, and now next will be that is minus 1 by s, and now its derivative is Euler Mascheroni gamma dance of s, and then sine pi s by 2, and last minus 1 by s gamma of s, and now this is cos of pi s by 2 times pi by 2. Okay, so now let us substitute what, s as 1. If you substitute s as 1, this will basically go to integral from 0 to infinity. X to the power 0 is 1, so ln of x si of x dx. So that's why we will make the change over here as well. We get, you substitute s as 1, we get gamma of 1 and then sine of pi by 2, that is all of this is 1, and minus, and this 1 by 1, and gamma dash of 1 is negative Euler Mascheroni constant, and sine pi by 2 is again 1, plus this is minus 1, this is 1, sine pi by 2 is 0, so overall it's 0. And you see we get the answer Euler Mascheroni constant plus 1. And yes, this is the answer. You can also do it without using this Mellin transform formula of si of x. You can also do it without this, but since we derived this in just the previous video, so I have used this and the problem became pretty simple. Hope you enjoyed the video. Thanks for watching. Look forward to the upcoming videos too.